In this video, we will be talking about the importance of using representative test specimens when you're setting up the calibration on a test instrument to perform testing of a specific variable, like conductivity. So this is an Olympus 600D, fresh back from the calibration lab, Olympus. So it is confirmed to be operating as it's supposed to. This has a specific conductivity probe from Olympus, designed specifically to perform conductivity tests using this tester. So it's going to be pretty darn accurate if we use the proper calibration samples and we test material that is within the range that we calibrated the tester on. So you want to use calibrated samples. Now, do I have paperwork with these? No, but they came off of this tester, which came from Hawking, and these conductivities were in that tester, so I'm assuming these are probably right, but I have other ways to check it. But we're going to, I already set up the calibration on the Nortec 600 using these two samples. So just to see if it's accurate, we're going to do the first sample, 8.65 IX. And obviously there's a hole here, my coil diameter is too large, so if you just set that on there, you're not going to get a good reading because you'll have liftoff. So flip it over on the large surface, and I'll hold my probe down, 865. That's dead on balls accurate, like they say in My Cousin Vinny. And then the next one is 50. Is it 50 or 59? 59? 59. 59. Oh. That's funny. I'm actually going to work that into this video. When I first read this, I thought it said 50. So I calibrated the instrument to 865 and 50. And then when I went to test the copper, I was coming up with 82. And I'm like, well, that's just outside the range. So it's important that you use the actual sample conductivity. Let's redo the cal using the right numbers and see how that fares with our test. So I'm just going to change that second value to 59. Then we're going to perform the cal again. So we're going to go to condition 1, 865. Store. I'm going to go to 59. That's the right number. Store. Then we need to get the calibrated shim, and I know that 4 mils is the tan one, which is this guy. These are calibrated shims. I know because I have the paperwork that came with the invoice. All right, so we're going to go 8.65 with the 4 mils. We're going to put coil right on top of that, make sure it's sitting flush. We'll hit store. Then we're just going to move it over. We're going to do the 59er sample and hit store. Success. All right. So now that we've used the right values, this one's 865, coming in at about, depending on how you hold it. You know, you got liftoff, temperature, surface roughness, but it's 865. Dead on balls accurate. 59 sample, it's coming in at 58.89. Oh, I wasn't on there exactly flush. How about now? Just shy of 59. Now what if we go back over to the 100? I bet you it's higher than 80 because we used the proper cal set points. Look at that. 103. So even though I went into this video with a certain intent, I noticed that I was off with my samples, and you can see how far off that can throw your test results. So your test results are only as good as your calibration. I hope you enjoyed the video.